Well, hello there. What's up? I hope that you're all doing very well and enjoying learning. You're very welcome to today's lecture on significant figures. I'm your own personal physics tutor, Dr. Rima McMullen. In today's lecture, we're going to discuss how significant figures propagate when you perform mathematical operations such as addition, subtraction, multiplication, and division on some numbers. Alright, let's begin our class. We're going to begin by looking at the rules of propagation of significant figures in mathematical calculations. You will see that there are two sets of rules for propagating significant figures in calculations. One set of rules is for addition and subtraction, and the second rule is for multiplication and division. Now you might ask, why do we have just one rule for addition and subtraction both? Well, subtraction is same as addition. How so? Let's say you are subtracting b from a. You have a minus b. This can be written as a plus negative of b. So subtraction is same as addition of a negative number. Does it make sense? I mean, if you have 5 minus 3, I could write this as 5 plus negative of 3, which gives you 2. So we'll have only one rule for both addition and subtraction because subtraction is basically the same operation as addition and vice versa. Similarly, multiplication and division, they are same operation. They're not two different operations. Again, how so? Let's say you're dividing some number c by d. Okay, you can write this as c divided by d like this if you wish. I could write this as c times 1 over d. Or I can write this as c times 1 over d like this. So division is same as multiplication by the inverse or the reciprocal. So division is basically the same thing as multiplication and vice versa. There is no difference between multiplication and division. Instead of dividing, you can multiply by the inverse, or instead of multiplying, you could divide by the inverse. So if I were to multiply two numbers, let's call it as e times f. This can be written as e divided by 1 over f, which gives us e times f. So all I'm trying to do is show here that multiplication and division are same operations and addition and subtraction are same operations. Alright, now we have this out of the way. We're going to look at the rules for significant figures for addition and subtraction. So the rule says the final answer should be rounded off to the same number of decimal places as the number with the least number of decimal places that you're adding or subtracting. I know it's a lot of words, so let's understand with the help of an example what we mean. Alright, so example number 1. We have a number 22.143 which is to 3 decimal places. That means it has 3 digits after the decimal. To that we're adding 391.79. So we know that the final answer must round off to 2 decimal places. Why so? Because the second number here that is being added, that has 2 digits after the decimal. So the second number, that is the number with the least number of decimal places. Alright. So we're going to pretend that there's a 0 at the 1000th place for the second number. Why? Because there was nothing there to begin with. And putting a 0 there changes nothing. And after we put 0 there, we're going to go ahead and add these two numbers. And when we do that, we get 413.933. Now, according to the rule, we're going to round off this final answer to 2 decimal places. So what have I done so far? I'm given two numbers to add. The first number has 3 digits after the decimal, while the second number has only 2 digits after the decimal. So we're going to pretend that there's a 0 at the 1000th place of the second number, which has fewer number of decimal places. And then we're going to go ahead and add these two numbers. After these have been added, we're going to round it off to 2 decimal places. We're going to round it off to 2 digits after the decimal. How do we do that? For that, we are going to look at the third digit after the decimal. because we are rounding it off to 2 digits after the decimal place. So the number we're going to look at is the third digit after the decimal. And if that third digit is 5 or more, then we are going to round up the second digit. But if this third digit after the decimal, it's less than 5, then the second digit remains itself. So we see that the last digit, the third digit, is 3, which is less than 5. Therefore, the second digit after the decimal remains itself. So the answer is 413.93. It was fairly easy. Let's look at example number 2. Now we have 814.39. This number has 2 digits after the decimal place. Alright, we're going to subtract 792.581 from it. Okay, so once again, the number of digits after the decimal is different for these two numbers that are being subtracted. The final answer must round off to 2 digits after the decimal place. So we're going to pretend that there is a 0 here at the 1000th place for the first number. Why? Because there was nothing there to begin with. Then we are going to perform the subtraction. And after we have done the subtraction, now we need to round off the final answer to 2 decimal places, to 2 digits after the decimal. For that, once again, we are going to look at the third digit after the decimal, and that turns out to be 9, which is greater than 5. What that means is the digit prior to this 9, which is 0, will round up by 1. And that will become now 021.81. So after rounding off, our final answer is 21.81. Very well. Now that we have gone over the rules for addition and subtraction, and we have looked at one example of each of them, we're going to move on to rule for multiplication and division. Don't worry, we're going to look at several more examples of rule of propagating significant figures for addition and subtraction. But before that, we're going to look at the rule and one example of each for multiplication and division. So for multiplication and division, the rule is different. Here, again, whatever numbers are given to you, go ahead and perform the operation of multiplication or division, whatever it is that you're asked to do. And at the end, the final answer, it would be rounded off to the same number of significant figures, to the same number of significant digits as are the number of significant digits in the number with the least number of significant digits. Again, a lot of words. But we are going to understand this rule with the help of an example. So we have two numbers that we are multiplying, 78 and 602. Now we know that this rule is related to the number of sig figs. 78. How many significant figures or significant digits are there in 78? Now, how do I tell the number of significant digits in a given number? I already made a lecture on that. I highly recommend that you watch that lecture if you haven't already done so, or if you don't already know how to tell the number of significant digits in a given number. I will put the link for that lecture in the description box for this lecture. Alright, moving on. So 78 has 2 sig figs, while 602 has 3 sig figs. So as per the rule, after we do the multiplication and we have the final answer, we're going to round off that answer to how many sig figs? 2 sig figs. Ready to do it? Alright. So the answer is 46,956. We need to round it off to how many sig figs? 2 sig figs. And we're going to totally ignore these last 2 digits. These do not matter. The only digit that matters is the third digit. Why does this third digit matter? Because we want to round it off to 2 digits. So we're going to look at the third digit and see if the third digit is 5 or greater. Then the second digit here, it will round up. If this third digit had been less than 5, then the digit to the left of it would have remained itself. But since this third digit is 9, what's going to happen is that the 6 over here, this will round up to 7, and all of these these will become zeros now. Okay, I hope this made sense. Let me know in the comments if these things are making sense. If there's anything I could do differently so it makes more sense, please let me know. Next example. We have looked at an example of multiplication. Next, we're going to look at an example of division now. So we have 1032 divided by 5. Okay. That gives us 206.4. Alright. So this first number, how many number of significant digits are here? 4. Okay. 5. How many number of significant digits are in 5? 1. That means the final answer must have how many number of significant digits? Only 1. That's what it should have. But 206.4, how many does it actually have? 206.4 has 4 significant digits. So we need to round it off to 1 significant digit. And for that, forget about this, okay? Whatever happens after the decimal, don't worry about that. So I've boxed in 1 digit, which is the first digit. We are bothered only with the digit to the right of this first digit. That is 0. So this 2 remains 2, and everything after it becomes a 0. Now, since the actual number was 206.4, does it mean I should have my answer as 200.0? No. Because if I write my answer as 200.0, then this will have 4 sig figs, not 1. So the answer is 200. Because 200 has only 1 sig fig. Okay? Alrighty. So here final answer is 200. Now it's the same numbers with one difference. Instead of 5, I have 5.0. And 5.0 has how many significant digits? 2. That means the final answer, which is 206.4, must have how many sig figs? 2. So once again, if I keep this decimal, okay, and I have a digit after the decimal, then I will have 4 sig figs. That means I have got to drop this decimal. You have to let it go. Now look at this number, 206. 206 has 3 sig figs. We want 2 sig figs. So we want to keep the first 2 digits as non-zero, and everything after that will be 0. So look at this last digit. It is 6, which is greater than 5. That means the digit to the left of it will round up. So it will become 210. That would be your answer. Final answer is 210. So once again, I have already made a lecture on rounding off to a certain number of significant figures. If you're finding this hard to understand, I suggest that you watch that lecture first. That would make understanding this one much easier. Anyway, I'm going over the rules once again as we are doing it anyway. Same problem. Now I'm dividing it by 5.00. How many sig figs are in 5.00? There are 3 sig figs. So that means the answer 206.4 should round off to 3 sig figs. So like I already said, that if I keep this decimal and the digit after this decimal, then the number 206.4 has 4 sig figs, while we need only 3 sig figs. That is the rule. So we want to keep the first 3 digits. To do that, we're going to look at this last digit. And since this last digit is less than 5, that means the digit to the left of it will remain itself. So the answer is 206. So we have gone over one example of rules for significant figures for addition, 1 for subtraction, 1 for multiplication, and 3 over here for division. Before we move on to more examples for these rules, let's quickly look at the rules one more time. For addition and subtraction, identify the number with the least number of decimal places. Perform the calculation. Lastly, round off the final answer to the same number of decimal places as the number identified in step 1 above. And in the step 1, we had identified the number with the least number of decimal places, which means the number with the fewest number of digits after the decimal. So these are the rules for the significant figures for addition and subtraction. Next, for multiplication and division. Identify the number with the least number of significant figures. Perform the calculation. Lastly, round off to the same number of significant digits as are in the number identified in step 1. Alright, so now we know these rules. The rules are similar but yet different. For addition and subtraction, we're looking at the number of decimal places, while for multiplication and division, we're looking at number of significant digits. So next, I have quite a few examples over here. Like always, I'm going to recommend that first you perform these calculations on your own and then check your answers. Okay. We have 1039.58 plus 98.0000. So you will notice that I have lined up the decimals. So as per the rules that we looked at on the last slide, first thing we need to do is identify the number with the least number of decimal places. That is the number with the least number of digits after the decimal. So that is the first number. Okay. So this first number has 2 digits after the decimal. That means the final answer must be rounded off to final answer, round off to 2 decimal places. Okay. And we have learned that at these spots, the 1000 and the 10,000, where there's nothing in the first number, we're going to put a 0 by hand. Next, go ahead and perform the addition. Got 0, 0, 8, 5, 7, 3, 1, 1. Alright, so to round it off to 2 decimal places, I'm going to put a line over here. Since the digit to the right of the line is just a 0, okay, that means this number, it will round off to 1137.58 only. This is your answer over here. This was quite easy, wasn't it? Let me do the number 2 over here. Same number, 1039.58 plus 98.00. So both of these numbers that are being added, they are up to 2 decimal places. They have 2 digits after the decimal for each of these numbers. That means the final answer will round off to 2 decimal places as well. So this is easy. When we add it, we get, okay, this is 7 over here, 3, 1, 1. This is your answer. We have to do nothing to it. We'll leave it as it is. Number 3. Again, we have the same numbers. 1039.58 plus 98.0. Now, in number 3, these 2 numbers are not to the same number of decimal places. The second number that is being added, which is 98.0, is up to 1 decimal place. That means the final answer must round to 1 decimal place. Let's go ahead and perform the addition. Okay. Alright, I'm going to put this line indicating that I want to round it off to 1 decimal place. So look at the digit immediately to the right of this line, which is 8. Since it is greater than 5, this 5 will round off to 6. So answer will be 1137.6. Okay. Alright. While we're at it, if we had, I'm going to change this a little bit, okay? If we had, let's say 7 over here, okay? Then this answer would have been 7 over here. But even in that case, we will look only at this 8. This 7 is not relevant. This 7 will not matter when we're rounding off this number to 1 decimal place. The only number that matters when you're rounding off is the digit that's immediately to the right of the digit that is being rounded off. I hope that made sense. So number 4 is also based on the same numbers, but different number of decimal places. So let's go ahead and do it over here. 1039.58, 98 point nothing. Okay. So I could have just as well written it as like this 98, which I have to now write like this. These 2 zeros, these were not there to begin with. I have put it in by hand here. So this answer must be rounded off to no digits after the decimal. So I get 857311. This will round off to, okay, let's put a line over here, which tells me that it is going to be rounded off to no digit after the decimal. So that means the 7 needs to be rounded off because this is going to become the last digit of the number that is rounded off. Look at the digit immediately to the right of the 7, and that is 5. That means when we take away these numbers, this 8, okay, hang on. Let me go back a bit. This 8, this doesn't even matter. Pretend like it's not even there. Just forget about it. The only number that matters is this 5. Why? Because we are going to round off the digit to the left of it. Okay. So since this is 5, the 7 becomes 8. Answer is 1138. Now this decimal, you can put it there if you want to. You don't have to put it. You could leave the answer as this, 1138 or 1138 point. But nothing will follow that point. I hope that this made sense. It's actually fairly easy once you get it. Alrighty, so we're done with first 4 problems. Moving on to problem number 5. 856.123, 5006.044. So once again, you will notice that I'm lining up the decimals here. It is very important to line up the decimal. Luckily, these 2 numbers that are being added, they are to the same number of decimal places. That means the final answer will also have 3 digits after the decimal because the 2 numbers that we're adding, they are up to 3 decimal places. Let's go ahead and perform the addition. So 7612685. Alright, and there's your answer. We got to do nothing to this. Alright, so that was number 5. Moving on to number 6. Number 6 is 856.12 plus 5006.004. Okay. Now this one, the first number is 2 digits after the decimal. That means the final answer must round off to 2 decimal places. Okay. Alright, this is supposed to be a 4 here. Alright, let's go ahead and perform the addition. We get 4612685. Alright, so since we want to round it off to 2 decimal places, that means we are going to look at the 3rd digit after the decimal, which is 4. Since this 4 is smaller than 5, when we take this away, that means the 6 will remain 6. So the answer is 5862.16. That's all. Number 7. Alright, again, same 856. No. Number 7 is different. But why don't we just look at this? Another example. If we had 856.1 plus 5006.0, I'm going to make it 7 here, okay? 74. I know that it used to be a 4 over here. I just changed it, just to illustrate a point. When I add it, I get, this is supposed to be a 2. I read this 6 as a 0. The 6, I read it as 0. Nothing should change over here. Now we know that we want to round it off to 1 decimal place. When we want to round it off to 1 decimal place, this 3rd digit after the decimal, this doesn't matter. Pretend like it's not even there. This 7 now, it does matter. Because this is greater than 5, that means this 1 will round up to 2. So the answer will be 5862.2. So this is just an extra example that I inserted in here to illustrate a point. We're done with problems 1 through 6. Moving on to number 7. 7 is 96.7408 plus 583.003. So the final answer. How many decimal places would you round it off to? 3. Because the second number that is being added is to 3 decimal places. And the first one is to 4 decimal places. Therefore, the final answer must round off to 3 decimal places. Let's go ahead and do the addition. So we're going to round it off to 3 decimal places. Therefore, we are interested in this digit, the 4th digit from the decimal. Since this 4th digit from the decimal is 8, when we get rid of it, the number to the left of it will round up by 1. So the answer will be 679.744. That is your number 7. Number 8 through 11. They are very similar. Okay, so let's do those on the next slide. Number 8. 379.838 minus 48.000. So both of these numbers are to 3 decimal places. We got lucky here. We'll have to change nothing. Here's our answer. And the answer remains itself. Nothing is required to be done to it. But why? Because the numbers that were being subtracted, they were both to 3 decimal places. Therefore, the final answer should also remain to 3 decimal places, which it is to begin with. There, it's done. Number 9. Things are going to change a little over here. We are going to subtract 48.00 from 379.838. So the final answer we know is 331. Well, not exactly the final answer, but you know what I mean. Okay, so how many decimal places this final answer must be rounded off to? Did you say 2? And is that because the number that is being subtracted, which is 48.00, has 2 digits after the decimal? Alright, so I've drawn this line which is separating 2 decimal places number on the left hand side. On the right hand side of this line, there's only 1 digit. So once again, look at the digit immediately to the right of the digit that you want to round off. If the digit to the right of the digit being rounded off is 5 or greater, then the digit will round up by 1. Otherwise, the digit remains itself. So since this 8 is obviously greater than 5, that means this 3 to the left of it will round up by 1. So the final answer is 331.84. Number 10. What does number 10 say? 379.838. I'm sorry, for these two, there's a space missing between this dot and the number. My bad. It's just an oversight. Minus 48.0. So in this case, the final answer should be rounded off to 1 decimal place. So we get 0.133. Now, pretend like this 8 is not there. Well, this 8 doesn't matter. Why? Because this is second digit from the digit that needs to be rounded off. So it does what? Matter. While this 3 does matter. But since this 3 is smaller than 5, the number to the left of it, the digit to the left of it, that we're trying to figure out if it would be rounded up or not, will remain itself. So the answer is 331.8. Number 11. 379.838 minus 48. This will be rounded off to no digit after the decimal. So this will give us 331.8 838, correct? So we want nothing after the decimal. That means we need to figure out if this 1, which would be the last digit after rounding off, if this needs to be rounded up or not. So since the digit immediately to the right of this 1 is 8, which is greater than 5, that means this 1 over here will round up to 2. While these digits, the second and the third from the decimal, they do not matter. So the answer is 332. Alright, number 12. Number 12 is 1504.032 minus 632.042. Now in this case, both of these numbers are to 3 decimal places, therefore the final answer will not need to be changed. Let's find out what the answer would be. 0, 30 minus 4 is 9, 9, 1, 10 minus 3 is 7, then we have 14 over there, 14 minus 6 is 8. Here's your answer, 871.990. Well, there's nothing to be done here. The numbers that are being subtracted are both to 3 decimal places, so is the final answer. Number 13, 1504.03 minus 632.042. Alright, now in this case, the first number is to 2 decimal places. So the answer must round off to 2 decimal places. We're going to pretend like there's a 0 over here. So this will give us 10 minus 2 is 8, 12 minus 4 is 8, 9, 1, 7, 8. So that's our answer. Alright, now we're going to look at this digit to the right of the line. So I put this line over here because I want to round it off to 2 digits after the decimal. We're going to look at the digit immediately to the right of the line. It is 8. For the last digit will round up. Answer is 871.99. Number 14. 1504.0 minus 632.042. Alright, before I work on this, the answer must be rounded off to 1 decimal place. So I have put this vertical line such that there will be only 1 digit to the right of the decimal. Now go ahead and perform the calculation. You get 8 here. We're going to pretend like these are zeros over here. So you got 8, then 9 minus 4 is 5, 9, 1, 7, 8. Alright, this 8 does not matter. This 5, which is immediately to the right of the line, does matter. Because this is 5, that means the digit to the left of it will round up. So the answer will be 872.0. Cool? Number 15. 1504 point nothing. 632.042. So the answer will be same as in the number 14. I'm going to put this line over here. Why? Because I want to round it off to no digit after the decimal. So this gives me 958, 871. So since this digit immediately to the right of the line is 9, greater than 5, the digit to the left of it will round up. And these 2 last digits, which are like the second and the third from the vertical line I drew, these do not matter. So the answer here is 872. Cool? Number 16. 17.18 times 200. Okay, so what's the rule for multiplication? We are going to identify the number with the least number of significant figures. And that is 200. 200 has 1 sig fig, while 17.18 has 4 sig figs. So the final answer must have how many sig figs? 1. So 17.18 times 200, what does that give us? 3436. So we want to round it off to 1 significant figure. So that means we should have only one non-zero digit, which will be the digit that we begin with. Alright, so I drew this vertical line indicating that I want to have only one sig fig in the final answer. Like before, disregard any digit that is to the second or the third or further from the line. Only the digit that's immediately to the right of the line matters. It is 4, therefore the digit to the left of it will remain itself. Answer is 3000. That's your final answer. 17. 9999 times 3.18. Identify the number of significant digits. 4 sig figs in 9999 and 3 sig figs in 3.18. So the final answer must have how many significant figures? Only 3. Alright, I'm going to use a calculator to do this calculation. 31796.82 needs to be rounded off to 3 significant digits. So here is the line such that there are only 3 digits to the left of the line. Why? Because we want to round off to 3 sig figs. Then we are going to focus only on the digit that is immediately to the right of the line. All the other digits to the right of the line do not matter. So the 6, 8, 2 don't matter. 9 greater than 5. Therefore, the 7 over here becomes 8. Answer is 318. Cool? Now we're going to look at examples of division. 893 divided by 2.2. First thing, identify the number of significant digits for each of these two numbers. 3 sig figs for 893 and 2 sig figs for 2.2. So the final answer must round off to how many sig figs? 2. Alrighty, 893 divided by 2.2 gives us log answer 405.9090909. We want to round it off to 2 sig figs. So here's my line, such that there are only 2 digits to the left of the line. All these digits do not matter. Only the digit immediately to the right of the line matters, and that is 5. Therefore, it's going to round up this 0 by 1. Answer will be 410, which can be written as 4.1 times 10 to the power 2 in scientific notation. Now, I have already created a lecture on scientific notation and significant digits. I will put the link for that as well in the description for this lecture. 19. 71 divided by 497. 2 sig figs for 71 and 3 sig figs for 497. So the final answer must have how many sig figs? Only 2. 71 divided by 497 gives us 0.142857143. Rounded off to 2 sig figs. So here is my line, such that there are only 2 digits to the left of the line. We need to look only at the digit that is immediately to the right of the line, and no other digit matters. So these do not matter. Since the digit immediately to the right of the line is 2, which is smaller than 5, that means the digit to the left of the line remains itself. So the answer is 0.14. Here's your answer. So here we have looked at quite a few examples of how significant figures propagate when you perform mathematical calculations. This was it for this lecture. I hope that it was useful to you. If you think that there's anything that I could do differently to make these lectures more useful to you, please let me know in the comments. I'll see you with the next lecture again very soon. Until then, have a good one.